Hello student, we start with the practical 4-bit magnitude comparator. If you see, these are the pin diagram of 4-bit magnitude comparator. Okay, if you see the pin number is max is 16. Okay, so it is 16 pin IC, you can call it as 16 pin IC. Okay, so these are the IC. See here, this one is IC. Here, this direction having the notch. Okay, if you visualize, this notch is exist like this one is notch. You can keep IC like this one, and below this one, okay, below this one, this is your IC number 1, pin number 1, then pin number 2, 3, 4, 5, 6, 7, 8, right? Above this one is pin number 9, 10, like this one, 10, 11, 12, 30 up to the 16. Okay, see, these are the IC. Okay, back side like this one. Okay, IC. Okay, then see the pin number 1, B3. Okay, so A3 is pin number 15. Okay, so these all pins we can marking by referring the data sheets. For before performing the all practical, all student, I requested all student first download the data sheet of respective ICs. It is mandatory for performing the before any practical, hardware based practical, you have to download the data sheets. Okay, so by referring the data sheet, we have to draw the such type of diagram. Okay, these are called as pin diagram. In the pin diagram, respective pins is refer for which purpose their labels are defined. Okay, so these are your output pins 5, 6, 7, 16 is VCC and 8 is ground, right? And we can see these are the 2, 3, 4, these are again less than, greater than, equal to, but these are the input pins we can utilize for the cascading purpose. And A0, right, A1, then A2, A3. Okay, these are the 1A, then B0, then B1, B2, B3. This is your second word B, and we have to draw like these are the diagrams for 4-bit comparators. Okay, if you observe, 8 is ground, 16 is VCC, this B0 to B3, A0 to A3, and pin number 2 and 4, that is input pins. Okay, so see here, 2 and 3 both are connected to the grounds, okay, and this A equal to B, this pin connected to the, we can call as VCC, this pin connected to the VCC, supply voltage. Okay, supply voltage we are connected to A greater than B. Output is 5, 6, 7. It is 5, it is 6, and it is 7. Okay, so 5 is A greater than B, 6 is equal to A equal to B. Okay, and A less than B, like this one. Okay, these are the, we can call as design and implement of 4-bit magnitude comparator. Now our aim is this diagram. Okay, by referring this diagram we can implement on the breadboard. Okay, see now how we can implement now. IC we can collect it. Okay, this is 7485 IC. Okay, comparator IC, like this one can from anywhere from this point like this one to anywhere you can connect. Okay, so we can one IC is required for implementation, so I have inserted IC like this one. See, the one side of pins will be inserted here, then you can see another side it will be inserted. Okay, afterwards you can press equally force, you can apply it and it will be inserted. Okay, so only we can take the precaution, there is no pin should be fold. Okay, these are the all pins here and here also, all pins will be there. Fine, so IC we can mount it like this one. Okay, notch is here. Okay, now afterwards we'll see the diagram. Okay, so very first connection is related to VCC and ground. So for VCC, your pin number 16, so this is your pin number 16. Okay, so 1 to 8, 9 to 16, so here 16, and you can reserve first one here is for VCC, so upper slot I have reserved for the VCC. Then same way 8 is ground, so we can connect 8 pin number connected to the ground, like this one you have to connect it ground. Okay, now see pin number 2 and 4 connected to the ground. So pin number 2, this pin number 2, right, connected to the ground. Then pin number 4, right, pin number 4, 2, then pin number 4, 3 and 4, right, this 4 connected to the ground, right. Then pin number remaining is only 3 equal to that, pin number 3 equal to be connected to the VCC supply. Okay, so pin number 3, this is pin number 3 connected to the VCC. So here connected to the VCC, right. Then 5, 6, 7. Okay, so 3 colors wire you can utilize, 3 colors, different colors wire. Okay, 5, 6 and 7. If available of the 3 wires, we can select and we can, according to that, we can mark, right, 5, 6 and 7. See, all 3 colors wires, okay, red, green and black. If it is possible to follow the color code, if different wires, flexible wire is available in the lab, we can utilize. Otherwise you can make the connection, there is no problem. Okay, so first one is your output pin number 5 is A greater than B. So count 1, 2, 3, 4 and 5. This one is 5. Okay, so we have connected here. Okay, so randomly one wire you can connect it here, so another one wire for the next wire you can connect here or here, up or down, not nearby, there is no chance of then short circuit. Okay, so 1, 2, 3, 4, 5, it is A greater than B, this one. Then green color wire. Then for the next is your red wire you can utilize, and this is for A. This one I have utilized for the next row. This one is A equal to B, red, and black I have used for the A less than B. A less than B. See now, A less than B. Like this one you have to make the connection. Fine. Now our next task is first verify the LED bank. Okay, LED bank you can test. How you can test, I will show you. See now how you can test the LED bank. Okay, these are your power supply positive, plus 5 volt supply is required, DC, and one is ground. So ground connected here and plus is connected here firstly. Okay, if the LED will glow, in that case we can utilize that. Okay, if LED will glow, then you can use for your connection. Okay, just I will show you. See the testing. This is negative connected to here and plus 5 volt supply connected here. If LED is glow, means it is okay. It not connected. Okay, means somewhat is somewhere is the problem. So we cannot utilize this LED now. Third one okay. Fourth one okay. Like this one you can test the LED bank. Okay, so we require the 3 output, A greater than, less than. So 3 LED we can utilize. So we will use first one, this one, and intentionally one by one. Okay, first, third and fifth we are using. Okay, thank you. Then see the connection now. See green wire, fifth number wire, it is A greater than B, we can connect in the first one. Okay, the second is A equal to B. Okay, A equal to B, we can connect here in the third position. Then A less than B, we can connect here in the 7 number position, right? And one additional wire we are using for the connecting the ground. This wire you can connect it, and this wire, okay, you have to connect it to LED bank. Okay, so like this we can connect LED here, right? And this ground, LED bank ground, we can connect it to the LED bank like this one. Okay, see now. Then see the power supply wires connected ground bottom side. Okay, and VCC wires, VCC of power supply plus 5 volt supply. Okay, this one is connected to above here. Here we can connect. Okay, and then you can see center LED will be blue. It is what? A equal to B. After making the connection, it is shown that A equal to B, because we are not connected B0, B1, B2, B3 as well as the A0, A1, A2, A3. If this wire you can connect it particular location, okay, as per the truth table, then we can see the according to truth table your LED will be glow. Okay, this condition is nothing but your A equal to B inside, A equal to B. Okay, when A greater than B at a time, fifth number LED, this LED will be glow. When A less than B at a time, this LED will be glow. This LED here, this LED. Okay, so in this way we implement the 4-bit comparator. Okay, thank you.